Hi everyone, welcome to RapidSyntax. Today we will be solving the question assigned cookies. So let's see what is this question. Assume you are an awesome parent and want to give your children some cookies, but you should give each child at most one cookie. Okay, each child I has a greed factor GI, which is the minimum size of a cookie that the child will be content with. And each cookie J has a size SJ. Okay, we are given with greed factor, for which a child cannot accept a cookie less than this greed factor, and we have been given a size array for the size of the cookies. Okay, if Sj is greater than or equals to Gi, we can assign that cookie J to the child I, and the child I will be content. Your goal is to maximize the number of your content children and output the maximum number. So what we need to do in this, we can assign a cookie to a child only when the size of the cookie is greater than or equal to the greed factor. And we need to find the number of cookies, or we can say we need to find the number of content child. And the child will be content only if we assign a cookie of size greater than to its greed factor. Okay, so let's see how we can solve it. So let's start by taking the first example in which the greed factor is this and the size of cookie is this. So first of all, let's start if when we are given with if we sort the greed factor and also sort the size of the cookies. Okay, so then let's start with the first greed factor and the first size. Okay. So compare. If it is greater than or equals to this, yeah, cool. So we will simply assign this cookie to this child. Okay. Now we will move to the next child and we will also move to the next cookie. Now we will check if this size of cookie is greater than this grid. No, no, no. Okay. Now the game plays. Okay. So what we need to do here? How means how we need to increase the pointer, like if we can assign that cookie, then we incremented both the pointers. But what if we were not able to assign this cookie to this child? Okay, let's see. This size of cookie is less than it is greed factor. Okay, so if we just increment this pointer, then obviously all the greed factor after this is greater because we have already sorted the cell. So if this size of cookie is not able to fulfill this greed factor, then how it will be able to fulfill the next greed factors which are already greater than 2? So yeah, we came to know that we can't increment this pointer. This will not be worth. Okay. So what if we will increment this pointer? Yeah, we can increment this. How? The size of cookie after this pointer will be greater than or equals to 1 because we have already sorted the size of cookie as well. Yeah, so if the size of cookie increases, then yeah, it might be able to fulfill this need. Okay, so we will increment this pointer. But no cookie is present after it. So it will finally return 1 because we were able to fulfill only one child greed. Okay. This was very small example. Let's see some big example for better understanding. So now, in this example, first start with first cookie and first child. Okay. So yeah, one is greater than or equals to one. Yeah, cool. So we can assign this cookie to this child. Very good. Now we will increment both the pointers. Okay. Now one is greater than or equals to two. No, no, no. So incrementing I pointer. Let's say this is an I pointer. And let's say this is the j pointer. So incrementing the I pointer will be not worth because the greed after the 2 already greater than 2 and 1 will not be able to fulfill two grids. So how it will be able to fulfill the grids greater than two? So we will increment the j pointer. Yeah. Now we will check for 2 is greater than or equals to 2. Yeah, very good. So we will increment this cookie to this child. Okay. Now, if we have issued this cookie to this child, then we will increment both the pointers, that is I and j. So yeah, now we will check if 2 is greater than or equals to 3. No, no. So we will increment the j pointer. Now, yeah, 3 is greater than or equals to 3. Yeah, yeah. So we will simply give this cookie to this child. Now, if we have given this cookie, so we will increment both the I and j pointers and they gets out of bounds. So finally, we will return our answer. Yeah, one thing I forget to tell. When we need to increment our answer, when the size of cookie is greater than or equals to size of, sorry, is greater than or equals to grid of child, then we will be incrementing our answer. So in this way, we, at first we will increment here, now at second we will increment at this, now at third we will increment at this. So finally the total number of content child in this example is 3. Okay, so I hope you get this. Now let's try code this approach. So what we were doing, we were first sorting both the arrays, that is grid and the size of cookie. Okay, so sorting the grid arrays and then sorting the size array, s dot begin, comma s dot end. Okay, now I will declare my result variable as 0. Now I will initialize two pointer I from 0 and j from 0. And I will run a loop till when I is less than g dot size and j is less than g dot size. If both are under bound, both are inside the bound of array, then only we will run this loop. Now we will check if, sorry, j is less than the size of cookie. If the size of cookie is greater than or equals to the size of grid, then we will increment our result and increment both the pointer. Else, we will simply increment the pointer of the size array of the cookie. When this we came out of this loop, we will simply return the result. Let's try run this. Yeah, it's working fine. Let's try submitting this. Yeah, it's good. Now let's talk about its time and space complexity. So you can see we are sorting this. So let's say if it is of n size, then in sorting the G array, it will take n of log n. And for sorting this, let's say its size is m. So it takes m log m. And this loop will run till minimum of n comma n. The smaller, okay? Minimum of n comma n. Because if any one pointer goes out of bound, then we will come out of this loop. So we can say what will be the overall complexity. If n is greater, then the complexity will be n log n. If m is greater, then the complexity is m log n. So let's say the complexity is n log n. I am assuming that n is greater than n. Okay, I hope you get it because finding its complexity is very simple. I am assuming that n is greater than m. Okay, cool. It also needs to be added. Yeah, now let's talk about space complexity. We are using this constant space for showing the result and this I and j. So space complexity will be big O of 1. Okay, good. So I hope you get this question. It was a very easy question and it was also very intuitive as well. Thank you for watching this video. Bye bye, guys.